Okay, so today we're into 10.7. 10.7 is the last new lesson for a while. We're continuing to solve systems of equations, meaning there's more than one variable, there's more than one equation. We need to figure out a way to play these off of each other to get solutions. The next day would not have a video or a lesson. It's just a day that if we were in school, homework would be turned in and we talk about it. So that's more of a work out your homework on your own. Email me, we'll do Zoom or something, kind of a day. There would be a practice quiz on 10, 6, and 7 soon, a quiz on that, review sheet for all of Chapter 10 soon, test on Chapter 10 soon, but it won't be a new lesson for a while in terms of videos and learning new notes and material and things like that. So you could continue to do any of three things with these. One is graph, which no one would choose that, I don't think. Because it's very hard to graph accurately. It's probably not the way you want to go. You could do substitution. If you feel like you dominated substitution yesterday, you could do substitution. Some of these problems are actually going to be a little bit better for substitution. So if you have any where you draw a blank how to start, maybe try substitution. But more of these are geared up today to do the addition method. So the addition method is designed to add the two equations together and hope that one of the variables will just disappear when you do that. And this first problem is laid out great for that, because if we add these two equations together with a subtracting y squared and an adding y squared, by adding those equations together, the y squareds, since they're opposite signs, would completely vanish. So if you see that, take advantage of that. 2 plus 6 is 8. Over here, remembering your invisible ones, that is going to become a 2x squared when we add. If you get the x squared alone, divide by 2 to get the 8 to be a 4. When you do the square root of 4, it's not just 2. The square root of 4 is also negative 2. And then we're most of the way done already. We just need to get ourselves the y's. You could go into either of these two equations to get the y's. At the moment, I feel like using this one because there's no negative signs in that of any sort. But if I had chosen this one, it would work. I'm not sure which one I picked on the paper, and I don't feel like walking to find my paper because I don't see where I set it down. So I'm going to just stick the 2 in here for x. X is 2, so 2 goes here. So we have 4 plus y squared is 6. Subtract that 4 to get a 2. When you do the root, the y could be the root of 2, or it could be the negative root of 2. And we just discovered for ourselves two answers. We just discovered that 2 could go with root 2, or 2 could go with negative root 2. And we still have this hanging. If we put negative 2 into this, when negatives get squared, they become positive. Negative times negative is positive. So when negative 2 goes into this, it becomes the same 4. And it'll follow that exact same path. Negative 2 would lead you to root 2. Negative 2 would also lead you to negative root 2. If you don't want to write the answers that way, another way you could write this answer in a sneaky way is plus or minus 2 plus or minus root 2. That describes all 4 of those pairings. This describes every partnership you could create of 2's with negative 2's. Positive, 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 negative. Negative, positive, negative, negative. Every partnership you can create by using those plus minus signs. It's a quicker way to write that. But you don't have to do that. You can write it out as 4 answers this way, because this is 4 answers still. If I go to do this problem, I have an issue here because I can't just add these together right now. If I add these together right now, there's no elimination of anything because there's no opposites. I'm going to have to force there to be opposites. This looks like a harder place to create that force because the numbers are different and the signs are the same. Here the numbers are different, but at least the signs are different too. What we want to have is different signs, same number. So what I'd like to have in this equation is a 5 right there. If this has positive 5, I'd love to have a negative 5. So I need to go through this whole problem and just multiply by 5s. There would be 15x squared minus 5y squared equals negative 5. Everything multiplied by 5. So I could call this A, I'll call this B, I'll call this C. What I'd like to add together now is A and C. If I add these two together, I would bump off the y squared opposites. I'd get 17x squared equaling a 17. 22 and negative 5 is 17. Get the x squared alone by dividing, that's 1. When I do a root, it's not just 1, it's also negative 1. And then I need to get myself answers for y's. I don't like the looks of this because it's bigger than anything I started with. I don't really like the looks of this because there's a lot of negatives, but I could use either of those. I just don't really want to. I'm going to go back to the top, I think, and try to use this because that looks like the easiest out of A, B, and C, although they'll all lead to the same spot. If I put the 1 in, 1 squared is 1, times 2 is 2, and the rest of this I just need to copy. To get the y squared alone, I'd subtract 2 from 22. I'll divide by 5 to get 4. When I do the root, it's not just 2, it's also negative 2. So I just located myself 2 answers. 1 could lead me to 2. This 1 led me to 2. 1 also led me to negative 2. If I try to follow this path, negative 1, when it gets squared, negative times negative is positive. Positive 1 times 2, that's positive 2. This is going to lead me down that exact same path I just traveled. Negative 1 could lead me to a positive 2. Negative 1 could lead me to a negative 2. And if you saw that comment, you might not have wanted to do the list of 4 that way, and maybe you want to write plus minus 1, plus minus 2. That's fine. There's 4 answers, whether you write it the long way or the short way. It's all good. This question seems easier, but it's actually sort of medium. Okay? We see the opposites, so that's good news. They're ready to add right now, and you're going to get an elimination on that. When you go add over here, there's a 12. Most beginners, if they add a problem like this, wreck it. Because not everybody realizes right away those are unlike terms. You're not going to be able to add these to get a single thing. When this adds this, it is x squared plus x. You can't add these. You have to write an adding problem. And now this is a different style than what we were doing. This is more like yesterday's. There's x squared, there's x's, there's numbers. You're going to have to get that equal to 0. The positive 12 would have to subtract 12. Factor xx. With a minus, we get different. Plus all is the bigger numbers, 4 versus 3. This tells me x is negative 4. This tells me x is positive 3, because I'm going to switch the signs. Then I have to choose between either level A or level B to go get the y's. I don't really like the looks of level B because there's negatives there, so I'd rather just go to level A. If I go to level A, negative 4 getting put in for x. Negative times negative is positive 16, plus y squared is 18. So y squared would be a 2, because I'd subtract the 16 to do an opposite. And when I do a root, it's not just positive root 2, it's also negative root 2. So I just found myself 2 answers again. The negative 4 for x led me to root 2. Negative 4 for x also led me to negative root 2. If I try to follow the 3, 3 goes into this. 3 squared is 9. 9 adds y squared to get 18. Doing opposites, subtract 9. Doing the root, it's not just 3, it's negative 3. So I just found 2 more answers. The 3 led me to a 3. The 3 also led me to a negative 3. So again, 4 answers on this. If I wanted to streamline this, I can't do it quite the same way I streamlined the other one. There is nothing to do with positive 4s in this. Negative 4 is just negative 4. You can't put any kind of plus minus sign on the 4. 4 is negative. What you could do is put a plus minus on the root 2. Likewise, the positive 3 for x is just positive 3, no variability there. But the y, you could do a plus minus 3, and that takes a little bit less space to write that if you want to do that. But if you don't like doing that, don't do that. It doesn't matter. For this last one, this is not at all set up for the addition method, because right now nothing is going to add together, and no matter what you do, nothing is ever going to be an opposite of anything else. That's basically impossible. So today, some of the addition method will, addition method will sometimes fail you. Just do substitution. Pick a letter, either letter. I set my notes down somewhere. I don't see them, so oh well. I'm going to get this x equals. I hope the paper got it x equals. If it didn't, then you've got two ways to do the same problem. If I get this x equals, 4 would have to divide by y, and that's my circle thing for substitution. Since I created that from equation B, it's going to get inserted to the other equation, equation A. So 16 on top of y squared, and copy the rest. Plus 4y squared equals 20 is just a copy from equation A. But when this went in and got squared, 4 became 16, y got squared. When you see fractions, people get often mad, so we can eliminate the fraction by multiplying y squared, because of the y squared on the bottom. If I multiply by y squared, that's going to eliminate, leave the 16. But that'll take this up to y to the 4th, and this will have to be multiplied as well, because when you do something to one item, we have to do it to everything. I'm going to get this equal to 0. I'll put the 4y to the 4th first, minus 20y squared, plus a 16 still equals 0. And then I'll look to factor. I'll take off a 4. So I have that. If I'm trying to factor y to the 4th kind of things, I'm going to go y squared, because if I go y squared, that's an effective way to make y to the 4th. With a plus, these signs are the same. They're the same as the other sign. With 4s, 4 times 1 will do that trick, because that adds to 5, so we're still good. This is a difference of squares. I can go y plus 2, y minus 2. This is also a difference of squares. I can go y plus 1, y minus 1. This would tell me y is negative 2, or 2, or negative 1, or 1. So there's a big column of answers. And then when we do substitution, we look to the circle. To get x's, I need 4 to divide by y's. So I'm going to go 4 divided by everything I just did. I put the y second, because y always lives second. So 4 divided by this, 4 divided by this, 4 divides this, 4 divides this, and that's the only way you can list these answers. If you try to abbreviate this with any kind of plus or minus, that would be a deception. If you try to put a plus or minus on this, they lead you to 2 different signs there. That's not a true thing. If you try to write this, this does 2 with 2, which is true, 2 with negative 2, which is a lie, negative 2 with 2, which is a lie, and negative 2 with negative 2, which is a truth. There's no way you can use this plus minus symbolism to shorten your answer up this time. You've got to just go the long route. That said, I would not do that problem very likely that way. I would encourage you to use common sense on some of these problems, and this would be one of them. When I look to this, I would think to myself, what ways can I multiply to get 4? 2 with 2, 1s with 4s, 4s with 1s. That's about it. If I'm going to multiply to get a positive 4, the signs would have to always be the same. Positive times positive is positive, negative times negative is positive. So I would think about these numbers and just like try them out in the other problem. If I try to put in this 2, 2 thing, 2 squared is 4, times 4 is 16, 2 squared is 4, 4s plus 16s make 20, 2 2s are a hit as long as the signs are the same. Negative times negative is positive, positive times positive is positive. I could find those from my times tables. If I try to 1 4, 4 squared is 16, times 4 is already way more than 20, that's a disaster. 4 1, 1 squared is 1, times 4 is 4. 4 going here, 4 squared is 16, 16 and 4 is 20. So 4 1 kind of partnerships work. As long as you keep the signs the same, that's also going to be a winner. If you understood that, you could save yourself a whole lot of algebra writing and do it that way. If you didn't understand that, that's fine. You can do the whole big algebra thing, no harm, it's all good. But there are a couple questions in this homework that you can common sense them. And the common sense might be easier sometimes than what the algebra is that presents itself. Just peeking at this homework, it's 457. Some of these are better set up for the addition method, like what I rehearsed the first few, but there are some that are better set up for substitution. So don't always get married to the addition method today. You might want to just sort of use a mix and match approach, because substitution is a better way to go on some of these. Number 2, the algebra on 2 is actually harder than most of the later ones. I might suggest trying to like common sense a little bit your way through 2. If you draw a blank on 2, let's zoom someday about it. But I'd say most of 1 to 8 are better set up for addition. Not 5, you can't add on 5. 5 is going to be a lot like this one with this XY thing. So 5 is either going to have to be substitution or common sense. But most of the 1 to 8, other than 2, I would look to probably do addition. 9, 10 look like addition. 11, 12, 13, 14, where the XY comes back in, I'd either go substitution or go common sense. But we'll work in that page. Email me if you have questions, we'll work it out.